Welcome to this episode of Easy Physics, where we will delve into the fascinating world of radar technology. Radar, short for radio detection and ranging, is a technology that uses electromagnetic waves to detect and locate objects in its vicinity. It has a wide range of applications, from weather forecasting to air traffic control, and even in military systems. In this episode, we will explore the working principles, components, and applications of radar technology. At its core, radar technology operates on the principle of emitting electromagnetic waves, which then bounce off objects in their path and return to the radar system. By measuring the time it takes for these waves to return, the radar system can calculate the distance to the object, along with other important parameters such as its speed and direction. This process is known as the radar echo. To understand how radar works, let's break it down into its key components. The first component is the radar transmitter, which generates the electromagnetic waves and sends them out into the surrounding space. These waves can be radio waves, microwaves, or even higher frequency waves depending on the application. The second component is the radar receiver, which captures the echoes of the transmitted waves that bounce back from objects. The receiver amplifies and processes these signals, extracting the relevant information such as distance, speed, and direction. To ensure accurate measurements, radar systems also employ a timing mechanism known as the radar clock. This clock precisely measures the time it takes for the waves to travel to the object and back. By multiplying this time by the speed of light, the distance to the object can be determined. In addition to these basic components, radar systems may also include a signal processor, which analyzes the received signals and extracts useful information. This information can then be displayed on a radar screen or used for further analysis. Now that we have a basic understanding of the components of radar technology, let's explore some of its applications. One of the most well-known applications of radar is in weather forecasting. Weather radar systems can detect rain, snow, and other atmospheric phenomena by measuring the intensity and frequency of the radar echoes. This information is crucial for predicting and tracking weather patterns, helping meteorologists issue accurate forecasts and warnings. Another important application of radar technology is in air traffic control. Radar systems are used to track the position and speed of aircraft, ensuring safe and efficient routing and preventing collisions. These radar systems can provide real-time information to air traffic controllers, allowing them to manage air traffic with precision. Radar technology also plays a significant role in military applications. It is used for surveillance, target tracking, and missile guidance systems. Radar systems can detect and track enemy aircraft, ships, and missiles, providing critical information for defense and security purposes. Beyond these applications, radar technology has found its way into various other fields, such as automotive collision avoidance systems, ground-penetrating radar for archaeological surveys, and even in sports applications like speed measurement in car racing. In conclusion, radar technology is an essential tool that utilizes electromagnetic waves to detect, locate, and track objects. By emitting waves and analyzing the echoes, radar systems provide valuable information about distance, speed, and direction. From weather forecasting to air traffic control and military applications, radar technology plays a vital role in a wide range of fields. Its ability to accurately detect and track objects in real time makes it an indispensable tool for various industries and sectors.